Welcome back to my lesson. Remember I promised that I was gonna record a lesson because I couldn't find or I couldn't properly record on the last time we had a lesson, so the video that I had didn't have a sound, and I was not aware when I was recording that the feed my voice is not being captured, so I ended up having a video which didn't have a sound, and it was just a useless video after that. So now I have to record again, and even for those who missed my lesson, like I'm always or the usual thing is after the end of the lesson I upload the video on YouTube so that you can catch up. And please, for those who are struggling to access this Google Meets or the apps blah blah, I feel like YouTube doesn't really need you to have a YouTube app. Like, you can just put the link on the browser and you can open YouTube from the browser. I don't think there is any phone which doesn't have a browser. I don't know, but I feel like any search engine that you have, you can basically just paste the link, YouTube link, on your search engine, and you can just watch the video straight from your browser. Like youtube.com, it's just a website that you can access via a browser. You don't necessarily have to have a YouTube app in order for you to access these videos. That is why I'm using the video the YouTube platform to upload this, so that you can easily access them. So I don't know, but yeah, I hope those who are struggling with Google Meets and stuff can actually utilize this, because I'm basically recording these videos for you guys, because it is important to have access to these lessons, since you paid for them, and yeah, it's not gonna be a good thing. Remember, this lessons comes once a week, so if you don't get an opportunity to attend live, then yeah, you can have a video that you can watch on your own time. I mean, you have 7 days before our next lesson, so you can watch this video anytime after the lesson, so that it can correspond with the document that I sent, because sometimes the document will be so messed up because I use that when I'm recording, so it means that it will have a lot of things written on it, and it will be a bit confusing to understand if you are not watching a video. But then this one is gonna be very short, because all I'm just gonna do is just to use one example for analytical geometry. This means that pretty sure that you know all the concept of geometry or analytical things like gradient, distance formula, midpoint. You all know that. So the main important thing in this topic is to know how to apply them, because knowing the distance formula, knowing the gradient formula, knowing the midpoint formula, and so on, yeah, you can know how to find the distance between the points, the distance between the 2 points and stuff like that. But they can be used in some different cases, so by doing this example, I'm just going to be applying analytical concepts, and just to remind you of the things that you forgot. Like, let's say you forgot other things, or how to find gradient or so, then that's what this video is going to do to you, to remind you of such things. Anyway, as you can see in this diagram, it says in the diagram below, there's a point D, there's a point E, and there's a point F. And as you can see, point F have a variable. So once you see something like that, you must expect that in one of the questions you'll be asked to find this value over here. So it might be something that you might be scared of. but expect that this question of finding the value k will be asked. And then they say these are the 3 points on the Cartesian plane. Okay, so as you can see in our diagram, so this diagram is the one that I'm going to be using throughout this video. Alright, so let me go to the first question. So the first question says that calculate the length of DE. So this one is easy. I mean, like, you just calculating the length between the 2 points D and E, and as you can see, all points are given, so you just write down your distance formula, and please write down DE because those are the distance, I mean this is the distance that you're calculating, so you have to specify which distance is it. So in this case the distance is DE, then is equals to, then you write down your x2 minus x1 squared plus y2 minus y1 squared. So now you can just go on to your points, maybe to just identify your x1 and y1, and then to identify your x2 and y2. So you're just gonna have your y2 like that. Now you're just gonna plug on the formula because there is nothing which is missing here, so it's a straightforward calculation. So this means that distance is x2, which is 3, minus negative 3 squared plus, and then y2 is negative 5 minus 3, and then you square that. And then now if you punch everything straight into your calculator, you will find that the distance is 10. So in general, just put everything straight into your calculator and get your answer. This question was just for 2 marks, so this means 1 mark for the formula, 1 mark for the answer. Okay, or maybe I'm just gonna do this, maybe 1 mark for substituting into the formula. All right, if I do this. Okay, then our second question says we should calculate the gradient of DE. So as you can see, you still are working with the same points, DE again. So I'm just gonna go ahead and do my thing. X1, Y1, X2, Y2. Alright, so this means that now you just write down your gradient formula, which is M, and then you write DE because this is the gradient that you are calculating. You are calculating the gradient between the points D and E, and then this is equals to y2 minus y1 over x2 minus x1, and then you substitute. Your y2 is negative 5, your y1 is 3, and your x2 is 3 again, and your x1 is negative 3, and you'll find that your gradient, if you calculate properly, is negative 4 over 3. So now let's look at our line here. You can see that you got a negative answer, which means that the gradient is decreasing, or the line is decreasing. This line is decreasing. So from this point to this point, this line is decreasing. So if you've done functions, then you remember that if you have a negative gradient, then the line or the function is decreasing. Okay, that's one of the things that it's an additional remark. Okay, let's move on to the next question. The next question says, determine the value of k, right? Remember, I said that once you see a variable in some coordinates, you will be expected to find that variable. So they say determine the variable of k if D, E, F. So let me just indicate over here, put a little head just to show that DEF is 90 degrees. So this means that the angle here is 90. This is the angle that we are looking at. E is here. So what does that tell you? What does this tell you? If you have two lines meeting at an angle of 90 degrees. Well, remember, in analytical geometry, we know that if two lines intersect at an angle of 90 degrees, then m1 multiplied by m2 is equals to negative 1. So this is one of the things that you have to know. Two lines. So if two straight lines intersect at a 90 degree, so if two lines are perpendicular, in other words, then the product of their gradients is negative 1. So now you can see that you be talking about a gradient of DE and a gradient of EF in this situation. And remember that you calculated the gradient of DF from the previous question, which was negative 4/3. And now you want to identify the second gradient. The second gradient is EF. So this is what is happening. This question is asking you to find the value of k. So in order for you to find this value of k here, you need to first find the gradient of this line over here. So they're giving you this tip, or this is a way of you finding the second gradient of this line. So in order for you to find this gradient of this line and you understand the meaning of this, then you can basically use this as a way of finding the second gradient. So we know that my m1 is mdA and my m2 will be EF. So if I just take these values and substitute over there, I'll have that MDE multiplied by MEF is equals to negative 1. So I know that MDE is equals to negative 4/3 multiplied by MEF, which equals to negative 1. Now I can just solve for this variable, and it will tell me that the gradient of EF is equals to 3/4. So this means that if I take this gradient and multiply with this gradient, I'll get an answer of negative 1. And this happens when two lines intersect at an angle of 90 degrees. So now I've done my first step, finding the gradient of this line. So this means that I can continue to try and find the value of k. So in order for me to find the value of k, I know that the gradient of EF is equals to y2 minus y1 over x2 minus x1, and then from there I can just continue and say 3 over 4 is equals to my y2. Let me do my thing of defining my gradients for my points. This is x1, y1, this will be my x2, y2. So I just like doing this so that yeah, I can just easily decide. It's just for me to, it's your choice. You don't necessarily have to start with this one, you can start with that one, but yeah, it's up to you. So I like to write down my x1 and y1 so that it's easy to just pick them up. So now my y2 is -5 and my y1 is the value k, and then x2 is 3 and y1 is -1, and this will be -5 minus k over 4. Now if I say 3 over 4 is equals to -5 minus k over 4, then I'm gonna cross multiply this denominator here to the left, and this will mean that this will cancel with this. If I have 4 here, this 4 will cancel with that, and I'll be left with 3 on the other side. And if this goes to the right, to the left as well, then it will become positive. So this means I will have -k is equals to +8 here, and if I divide both sides by -1, then I will have that k is equals to -8. Please try to do this fully, because I just used inspection from here to the answer. Okay, anyway, so now you can see that finding the value of k needed you to start by finding the gradient of EF, which in this case, for you to do that, they told you that these two lines, they intersect at an angle of 90 degrees. So you use this to find the gradient of EF, which we found that is 3 over 4, and from there you write down your gradient formula for this gradient now, but at least now you know its value. So what you do is that you just take this part and you substitute your values in there, then you simplify them, and then from there you solve for k. Right, now let's move on to the next question. The next question says, if k is -8, you see now they told you that k is -8. So this means that in this case, if you didn't find -k, then maybe some of your calculations might be wrong, but you can actually easily continue to find this question right, because now you don't have to worry that you couldn't find the value of k, but they gave you now in this question that k is -8, and you can still continue to work out this question. But here is what you have to notice. The questions in analytical, they follow each other, so it means the first question will follow, and the second question will need you to use the question from the the answer from the previous question, and so on. So you must pay attention to the way you do your work and understand how these questions link. So in this question they say, from the previous question we know that k is equals to -8, but that's just me saying that. They just basically say, if k is equals to -8, then determine the coordinates of M, capital letter M in this case, for midpoint of DF. So if you look into this diagram, you can see that DF is the point between this D and F over here. So you can just actually join them so that you can see the midpoint that they're talking about. So the midpoint will be somewhere here. That will be the M that you have to calculate. So using the midpoint formula, which is capital letter M D F is equals to, and then we have x1 plus x2 over 2, and then is to y2 minus y, not this, yeah, but it's actually like y1 plus y2 over 2. So this means that this is for the x coordinate of the midpoint, and this is for the y coordinate of the midpoint. Then you substitute in the formulas the values that you have. Like, let me just go ahead and do my thing here: x1, y1, then x2, y2. And now that I know the value of k, it means that here my new point will be -1 is to -8, which is f. So I can just, write this properly. Now, substituting in the formula, I'm gonna have x1 is -3 and x2 is -1 over 2, and y1 is negative, it's actually 3, and then y2 is -8, all divided by 2. So I actually made a mistake here. I wrote negative, or instead of saying plus, and this one is also plus. So this means that here I'll have an x coordinate of -2, and then I will have an answer of -5 over 2 in this side. So this means that the midpoint for this question is -2 is to -5 over 2. So, and you can see both of these coordinates are negative. As we can see, they are on the third quadrant of this Cartesian plane, so it makes sense to have all your points negative in this case. Now let's move on to the following question. The following question says, determine the coordinates of G such that the quadrilateral DEFG is a rectangle. But if you look into this diagram, you can see that you don't have a rectangle and there's no point G. So what you have to do is that, okay, you look into your diagram and they say we need a point G such that the quadrilateral DEFG. So you follow the sequence of these letters. It starts from D, and then it says E, and then it says F. So it means G will be somewhere here. I'm just gonna put it here. It can be here on the x-axis or somewhere above, but this is just me estimating where G could be in this diagram. And then I try to join the lines to have that legal triangle that they're talking about. Alright, now you have your triangle that you can see. So you have your G. Let me write down that this is G and the coordinate is X and Y. So this is what I'm looking for. Now you might just be like, now what can I do now that I have a triangle, I'm in a rectangle, and I do not know how am I gonna find this point? Well, remember, from the previous question, you were told or you were asked to calculate the midpoint of the line DF. So the line DF was in this way. So this was the line DF that you had to find the midpoint for, which we found that it's somewhere here. And remember, so in this case, that this line now will now become a diagonal in this triangle. So if you join the points to form a triangle at point G, the line DF now becomes a diagonal. So this means that I can have another diagonal from point G to E, and this diagonal will also pass through that point which we calculated our M over there. So what does this mean? In properties of the triangle, one of the properties says that the diagonals of the rectangle intersect, so they meet at a certain point. So this means that the diagonal GE has the same midpoint as the diagonal DF. So now it means that you can use the coordinates of midpoint to find the coordinate of G. So it means that now you have the point E, and then you have the point M. Let me write down the point M, which will be negative 2 is 2, 5 over 3. So I'm just gonna write it here. That is my midpoint. So you can actually find the point G by using this midpoint and the other point, long as they are on the same line. So what you do is that you write MDF is equals to not M for gradient but M for midpoint. So this is capital letter M, and this is M. This is a subscript DF, M subscript DF, and then this is capital letter M subscript and GE, which is equals to, and then you write down the coordinate, which is negative 5 over 2 in this case. Right, now midpoint GE is equals to x1 plus x2 over 2, and then y1 plus y2 over 2. So remember that you use this formula to find the coordinates, but now you have the midpoint, right? And you want to find the value of the other coordinates. Now this means that what you have to know is that this is equals to the midpoint over here, and this will also be equals to the midpoint over there. So this, like I said, this is for the x coordinate of the midpoint, this is for the y coordinate of the midpoint. So you have a midpoint and you will have another x coordinate, and this means that you can actually determine the other x value. So in this case, I mean that negative 2 will be equals to x1 plus x2 over 2, and in this case I'll have negative 5 over 2 is equals to y1 plus y2 over 2. Okay, so what you have to do now is to substitute the points E over here, because you have them. So you can just take that as your x2, y2. So this means that you can just have negative 2 is equals to, then your x1 is x, and then your x2 is 3 over 2, and then for the y is negative 5 over 2 is equals to, your y1 is y, and your y2 is negative 5 over 2. So now you just apply your algebra, like you can just take this denominator here and multiply it to the left side. So you just do cross multiplication, and then you do the same thing on the other side, cross multiplication. So here, if I do that, this 2 will multiply the 2 on the negative 2 on the right side to give me negative 4. And if I take negative 3, positive to the other side, it will also be negative. So this means that my x coordinate will be negative 7 in this case. And then here, doing the same thing, this 2 will cross multiply to the right, to the left, and it will cancel with that, and I will remain with negative 5. And then on the right side, I will have y minus negative 5. And if I take that 5 to the left side of the equation, it will become positive, and this means that my y coordinate now will be 0. So please do this in full. I'm just using inspection here because this is just algebra, solving for x in this case, and then here is solving for y. So you just cross multiply and take the like term to the same side of the equation, cross multiply, and this will also go to the other side. Then you get the x value of negative 7, y value of 0. So therefore the coordinate g will be negative 7 is 2, 0. And you can see that well, my guess was kinda a little bit correct, even though I took that value to be a little bit upwards of the y-axis. So if I can just have my coordinate over here, then it will be on the x-axis because the y value is 0. So I'll have a point negative 7 is to 0 at g. So that is the actual coordinates of g. Okay, so that is how we use the midpoint formula to determine another coordinate if I have the midpoint and the other point. Okay, let me move on to the next question. Well, this one it doesn't have a diagram, so it means that you can just try and understand what this question wants you to do. So we can see that we are given that point C has a coordinate of 1 and 2. So not 2 but negative 2. So you can write that and say C is 1 is 2 negative 2. And then they say point D lies on the second quadrant and has a coordinate of x is to 5. And then they say, so it means D is x is to 5. And then they say if the length of CD, so this means that we're talking about the distance now, if CD is equals to root 53, then calculate the x value on this coordinate. So here, no need for a diagram, you just asked to find the x coordinate. So it means that we're just gonna apply the distance formula. So distance formula CD is equals to x2 minus x1 squared plus y2 minus y1 squared. And then we know that the distance CD is root 53. You substitute the distance by 53. And then here on this side of the equation, you're gonna substitute your x2, your x1, y2, and y1. So from this, you can just conclude that this is your x1, y1, x2, y2. Okay, then you write on your formula, substitute x2 is x, and then x1 is 1 squared, and then you say your y2 is 5 and your y1 is -2. Then you square that, and then you just simplify what you can simplify. So which means this side there's nothing more to do because we do not know the square root of 53 is just a square root of 53. Yeah, square root of 53 is square root of 53. So yeah, it's not a perfect square, let me put it like that. So this means that on the right side we have our x minus 1 squared, and then here this you can just do that straight in the calculator to get an answer of 49, because this will be 5 plus 2, which is 7. 7 squared is 49. Now you are here and you need to solve for a value of x. So what you're gonna do is, to get rid of these roots, you will basically have to square the both sides of this equation. So you will have to write everything and square the both sides. So let me just write that in red so that it can be seen what I've done. So that square on the left and square on the right. This will cancel this square root, this and this will cancel, and then the answer will be 53, and then even here this and this will cancel, and then you'll have x minus 1 squared plus 49. Now you have to apply your algebraic skills to solve for x. So what you do is you just take everything to the right side of this question. So you're gonna have x minus 1 squared plus 49 is minus 53 is equals to 0. So in this situation, you can see that you are actually going to have a quadratic equation. So this means that you have to expand this bracket and apply FOIL to get a quadratic equation. So let's do that on the next page. So you will have x minus 1, and then you expand it to be x minus 1 multiplied by x minus 1, and then you have plus 49 minus 53, which is equals to 0. Then you apply FOIL, something that you learned in the first term of your school. You FOIL like that, and then this means you are multiplying two brackets. So you will have x, no need for a bracket now, it will be x squared minus x plus 1. So this means that it's x multiplied by x to give you negative x. No, I mean x multiplied by x is x squared. The negative 1, no, x multiplied by negative 1 is negative x. Then negative 1 multiplied by x is negative x, and then negative 1 multiplied by negative 1 to give you positive 1, and you will have your plus 49 minus 53 again is equals to 0 on the right side. So you will basically have to add your like terms here now. So you will have x squared minus minus 2x. This will give you 1 plus 49 is 50 minus 53, which will be negative 3, which is equals to 0. So what you're gonna do is to factorize this now. So it means that we had to manipulate this whole equation so that it can be easy to factorize. So now I can actually have factors for this equation. So it will be x and x. Remember, this side is equals to 0. Then I'll have 3 and 1, and this side will take a negative sign, this other side will take a positive sign, and then you factorize to have x is equals to negative 1. No, I mean you solve so that you have x is equals to negative 1 or x is equals to positive 3. So remember, these are just suggested solutions. Okay, we have to actually take the correct answer for the value of x on our coordinate d. So remember that they said that d lies on the second quadrant. So this means that if I draw a Cartesian plane, it's gonna have something like on this side all the coordinates are positive, x, y, they are all positive. On this other side I have negative x, and my y side coordinate is negative, and then on this other side my components are all negative, and then in this side I have positive x and negative y. So this means that if they say that d lies on the second quadrant, then this means it is here. So as you can see, the y value is positive, but now I have to have a negative x coordinate. So this means that on the answers that I got for the x, I need to take the correct one. So your solution does not necessarily have to end here. You have to accept the right answer. So you will have to say accept x is equals to negative 1, and then you say reject x is equals to 3. So you are taking this as the right answer for the x value. This is not the correct answer for the x value on our point D. So it means that your point D now will have a coordinate of negative 1 is to 5. And that is how you use the distance formula to solve for x. So this means that you have to know algebra in this side. Your algebra skills have to wake up. If you forgot a little bit about algebra, you have to go back and do a bit of practice, because this is important for you to know. You will have to use algebra a lot in this topic because it involves variables, equations, and if you forgot some of the basic algebraic skills, I suggest you go back to revise them. So as you can see, we used a distance formula. We were given a distance, and now we substitute from the distance formula the distance that I was given and the coordinates that I already have, and then I try to solve for this x here that I didn't know how to solve it. Maybe in this situation you might not have an idea of what to do, but basically you just have to remember that to remove or to get rid of these radicals, which are square roots in this case, you just have to square both sides. Then this will cancel with that. Remember, the reason for that is because in exponents, you know that if you have a square root of a and you write it in exponential form, it will be a to the power of 1 over 2. So if you square that, you put it and you raise this to the exponent of 2, This means that applying that exponential law where like the exponent from the inside will multiply with the exponent from the outside, you will have something like a to the power of 2 over 2, and this will give you a to the power of 1, and any number to the exponent of 1 is the same number. So that is the reason why we are squaring both sides to get rid of this root. It is because of this exponential law that you've already done actually in term 1 as well, if I remember properly. So yeah, all these things that you learn, you must be able to apply them in different situations. It's not just about learning them, but you also have to remember that if you come across something like this, you must remember, oh, this is what I have to do. So this is maths, and yeah, so maybe for this question you had to apply that so that you get rid of the square root, and then it will be easier for you to actually have this towards the quadratic equation. And you solve for x, you will get 2 solutions, but remember to take the correct one according to the conditions that you were given. So we are done with my question, and I think that me doing this will help you to understand a little bit of analytical geometry. So just to summarize things that have been covered in this question, the first one is the distance. So we used distance formula twice in this question. The first one was just a straightforward one. We just had to find the distance between the 2 points, and the second one we had to use the distance formula to find a coordinate from one of the given points when you know the distance. So the second one is the gradient. So we had the gradient formula which we used to find the gradient between the 2 points, and then we also used the gradient to apply in a situation where we have perpendicular lines. So if lines are perpendicular, it means that m1 multiplied by m2 is equals to -1. And then another thing with gradient that you have to know is that if 2 lines are parallel, so this means this is 2 lines which are parallel, their gradients are equal. So m1 is equals to m2. So you might see that in some of the questions where maybe they will tell you that if 2 lines are parallel, what is the gradient of the other line? So if you know the gradient of one line, then you can know that the gradient of the another line will be the same as that one, since these 2 lines will be parallel. And then the third thing in this question, another thing that we looked into in this question is the midpoint. So we used the midpoint formula to find the midpoint between the 2 lines, and we used the midpoint to find another point if I am given the midpoint. So if I know the other point and the midpoint, then I can use the midpoint to find the third point on my lines. So that was all for this question or this lesson. I hope it will make you understand this topic better, and thank you. Until we meet again on the next Thursday. Hope if you watch this video before that, then that will be good for you. Yes, enjoy this video. Thank you.